Salutations, fellow enthusiasts. Coming from my previous video, I'm getting into the spaghetti and mince, walking you through an example implementation of my tag-based state system, how to use it from start to finish. Showing you this mockup, this here is what we have logically in our head, a collection of tags that we want to implement. You're able to see over here that we have the regular tags idling, moving, walking, running and jumping, akin to the previous video's example, and the operator tags not and or. These are all tags, and we'll see how it works as we continue on with the project. Getting into it, let's take a look at the GitLab repository. This is my project Al Ghoutage, a video game created in the Go.game engine. It has a few key features that I'm focusing on, as you are able to see here, the tag-based state system being one of them. It's open source, so you may feel free to browse the code and get to understand it, peanut butter jam it that way. But getting on, we are going to download the project. You are either able to download in a variety of formats over here, the latest version of the source code, or you're able to clone the entire Git repository if you so wish. Once you have it downloaded, we shall extract it. And in this project, you'll find the relevant code relating to the tag-based state system under scripts, tag classes. Here are all the tag codes, tag classes, the tag classes. So for the sake of foresight, I'm going to go ahead and create a new folder because we are going to be creating a new Godot project and only extracting what we require from the Al Ghoutage project. So I'm going to go ahead and create an empty folder, and I'm going to call it the tag-based state system example. Okay, and we can go ahead and open up Godot and begin our new project. Name it tag-based state system example. And we'll navigate to our required folder, our designated folder. We'll be using OpenGL ES2 because OpenGL ES2 is more compatible with more platforms, and as a matter of fact, my laptop does not support ES3, so that's a fair use case there. Okay, so let's copy over the relevant classes. So scripts, tag classes, I want to copy over to the project, and just for the sake of organization and good code, I'm copying over one of my script templates as well. You'll see it soon. I based it off of the PEP 8 standard by specified by Python in the Godot documentation. It is in the style guides on the Godot documentation. Either way, opening up the Godot project, we'll see that the appropriate folders are imported automatically. And let's begin with creating the states or tags. Tags and states are used interchangeably. In this system, tags are resources, and they are defined by these classes. The files here under tag classes, I'll show it to you in the file manager. Here we have the generic tag, which is an abstract class for all tags. Then you get the regular type of tag, and you get an all operator tag and a not operator tag. Tags table is a depreciated piece of code, so that won't be used in this example. And tags is a sort of manager. It contains helper functions that help us to set the tags. Okay. So let's get creating. I'm going to create a new folder, and I'm going to make it our tags. This is where our tags are going to be stored, and we'll start by creating a new resource. The resource is of type tag. I want to start off by creating a regular tag according to our mockup. We will be creating the tags idling, moving, walking, running, jumping. They are all regular, and the operator is not and all. Okay, let's get started. Tag idling. Tag moving. Tag walking. Tag running. And tag jumping are our regular tags. As for the OR and the NOT tag, we gotta use the tag operator OR and NOT class respectively. And I'll name it tag OR. It's relating to walking, running, and jumping, so I'll just call it WRJ respectively. Yes, and not forgetting the NOT tag, not moving, because it relates to not moving. Okay, well, that tags created, let's take a look at them. Let's start with tag idling. You can see that each tag has 3 variables at least: name, value, and dependees. For now, I don't recommend defining the dependees variable from the inspector because of how Godot currently internally handles cyclic dependencies. Rather wait for Godot 4, which is said to have better support for that. So let's name these tags. I'll name these. The names of the tags are not do not affect the process or the code itself. It's just for debugging purposes. You could name it whatever you want, but I'll just name it appropriately for now. So this is a bit of a grind, getting all these tags set up, but once we have it set up, it will work quite nicely, hopefully. Okay, got it. Now let's connect these. Now let's connect these tags. Here is a diagram showing you the relationship between tags and the terminology used. Both of these tags are connected. They are both called dependencies, and the depender is the tag that depends on another tag, and the dependee is the tag depended upon by the depender. Okay, that's English for you. And we connect these tags with code using the function. We take the dependee and we add the function add dependee, and in parentheses we add the dependee. So let's begin creating the code. I'm gonna create a folder and I'm gonna name it scripts. Since tag classes is also a collection of scripts, I'm gonna drag and drop it into that folder, and let me go ahead and create a new script. The script I'm going to call tags example, because it's excuse me, it's because it's an example implementation of the tag-based state system. And you can see over here that my main template class is picked up. It's because it's in a folder called script templates, and that's a special folder that Godot recognizes. Any class that's under script templates is picked up as a template. Okay, let's open it up, and over here you're able to see that this is my template, and it does encourage good code organization. So to make use of tags, we refer to them with variables, and there are 2 methods of doing this. We are either able to export the variables and drag and drop the resources into the inspector, or we are able to preload or load the variables using the file paths of the resources. So let me start off with showing you the exporting method. Let's say, for example, we want a variable called tag idling. We shall export it as a resource, and I'll save that and I'll attach it to a scene so that we can get it shown up in the inspector. So I'll just create a folder for scenes, and in the scenes folder I'll create a new scene. I'm going to call it test scene, and in the scene I'm going to just create a regular node and attach the script tag example, and then we should see the tag idling in the inspector. From here we are able to go into our tags folder and just drag and drop the appropriate tag to the appropriate variable, and that is how you refer the tags. So you can go ahead and copy this and do it for each and every tag. So for example, moving and then walking, and you'll have it sorted out. The other method is to load or preload using the load or the preload functions. I do prefer this method because it does help the auto completion, and to do it this way we're going to create a variable and we're going to call it tag idling, and we load it. Preloading in this case is better because it does help the auto completion more than loading. And then we gotta put in the tags file path. We can just drag and drop it into the script editor to get the file path automatically. Okay, now a neat trick about preloading, because preloading happens at pass time with GDScript, we can actually make these constants and it works just fine. And constants are generally better for performance, so I would go this direction. Now we just gotta, firstly let's put it in the appropriate section. Okay, and now we gotta just copy it over for each and every tag. Now for this example we have about 7 tags. It's not gonna be very taxing or monotonous to copy and paste and drag and drop each of these tags, but if you have an intense example and have plenty of tags, things can get pretty monotonous. So let me show you a method having fun with text manipulation. If we open up this folder and we open up a terminal in the directory, we are able to list out each file in the folder using the find command. This will list out every resource in the folder. We can copy paste that and open up a text editor. Then we are able to paste in these, and to get the full path we can copy over this path, activate the block, select mode, and for each resource paste in the path like that. Since Godot uses the resource shortcut, we shall just put in the resource shortcut appropriately like that. Okay, next up, for each line we are going to make a constant. We're going to name it the tag, and we are going to add a few spaces there just for the name, and we're going to preload each of them. Okay, now we're going to take these names, we're going to put it somewhere safe, and we're going to remove the tres strings, and using regular expressions I'll remove any trailing spaces at the end of the line, and I'll replace it with nothing. Okay, that works nicely, I hope. Okay, next up we can just copy and paste it and overwrite it to the appropriate section. Okay, like that. And then finally, just to each line quotation and a bracket. Okay, there we go. Text manipulation for the win. So pick your poison. You can either drag and drop or do some text manipulation. But like I said, in an intense case when you have plenty of tags, this does show its worth. Okay, now that we have our tags referenced as variables, we are able to connect them together using the add dependy function. Let me show you the relevant functions. These are going to be add dependy, where you take the depender, you add the dependy, and then you take the depender, you put in the add dependy function, and in parentheses you add the dependy tag. Then also we're going to use the tags class, and we're going to be creating tags class is basically the manager of all tags. So we're going to have to create a tag object and specify all of the tags used in the current system. Okay, and these are for getting and setting. We'll get to that. Okay, so to begin with, I'm gonna make a init function. So at the start of the scene, we'll connect these all together. So according to the mockup, idling is connected to not to moving to or to walking, running, and jumping, and walking, running, jumping are all respectively connected to moving. So let's get that done. Tag idling is connected to tag not is connected to tag moving is connected to tag all, and tag all is connected to tag walking. Let's copy paste that. Tag walking, tag running, and tag jumping. And then tag walking is connected to tag moving, also tag running is connected to moving, and tag jumping is also connected to tag moving. And that's about it. We have our tags connected. So additionally, we're also going to have to create a tags object. For that, we require an array of all the tags, the appropriate tags. So to do that, I'm going to go ahead and create a public variable, and I'm going to call it tags. It's going to be of type tags experimental. That is because, if I can show you here, the tags class is named tags experimental. This is because of all the iterations that I've been busy with. Maybe I'll probably eventually just cut it down to tags, but for now we're dealing with tags experimental. Okay, onwards. Okay, so we gotta define the array as well. So it has to be new. Let's just call it tags array prospectively quickly, and then we're gonna create the array tags array. It's gonna be, let's open up that kite thing again. Let's just copy that over, just like that. Simple enough. Oh my gosh, never mind, we have to add commas to all of them, but not a problem. Just make it a comma. There we go. Copy paste that. Thank you. Great stuff. Okay, in the tags array we have the tags object. Great stuff. We have the dependies and the tag array and the tags object. So if I can give you more explanation on what the tags object does is, say for example, I want to be running, But for me to be running, moving would have for running to be true, moving would have to be true. The or would have to be satisfied. This not would have to be false, and idling also as a result become false. So we can either do that manually, or the tags object just does it automatically the moment we set running to true. So that is what we are going to be doing. Now that we have the tag set up, the tag resources set up, and the tags object or the tag object instantiated, we are able to go ahead and get into a more visual aspect of this project. We can start adding some movement code and creating a scene where things are actually visible. Okay, so let me go ahead and save the code, save the scene. I'm going to make a new scene, and this is going to be the player character. I'm just going to go ahead and call it player character. Oops, not capitals. And the player character is going to be a kinematic body, 2D. We're going to be creating a 2D game, and this requires a sprite. So I mean, it doesn't require, but to see things we require a sprite. So I'm going to go ahead and just real quickly create a sprite, a very simple, nasty, not nasty, everything is beautiful, a quick and easy sprite. We're just going to make it a triangle, and I'm going to color it in cyan, just why not, you know. And I'm going to save that under the appropriate folder. Okay, I'm going to create a folder for graphics, and I'm going to call it triangle. I'm going to save it as a PNG, that's fine. Yep. Okay, so there we go, it's imported. Graphics, great stuff. Let's drag and drop that, because that makes things easy, and we are able to put this in the origin. Great. Kinematic body also requires a collision 2D. Collision shape 2D. We'll create the collision shape to be a triangle. 3 points using the coordinates -16, 16, 0 on top, -16, and 16, 16. Right. So that creates a triangle collision shape. It's pretty fine. And I'll name this scene, this node, play character. And I'll attach. Oh, there's no code to attach just yet. We gotta create the code. We're gonna create some movement code for this player character. But for now, let's go ahead and save it. And let's create a stage. I'm gonna create a new scene. I'm gonna make it a node. I'm gonna call it stage. And in this stage, I'm going to add the player character, just so that we can see it visually. Let's start playing the game. Let's choose the stage as, oh, I didn't save it. Did I save this? No, I didn't save it. Save it as stage T scene under scenes. Click stage as the main stage, the main scene. Okay, and then we have something visible. Now let's start adding some behavior to this and getting the tag-based state system involved. Let's start by creating a script for the movement. And I'm just going to call this script movement. Okay, let's open that up. Empty. Okay, let's begin. Now what I did do here is I did some extra effort beforehand, and I do have a reference for this movement code. It is a bit big, but I'll explain it to you as I copy pasta. So let's begin with the ready function, as things usually are done. in the ready function at the start of the scene, at the start of the stage, we want this code is going to be attached to the player character, and we want the player character to start off in an idle state. So to do that, I'm going to show you the relevant code again. Here we'll be using tags, the tags object, tags.set tag, and we'll put in the relevant tag, and we'll put in the value that we want, that being true or false. And also to read the tag's value, we'll put in the tag.get tag value. Okay, so we want idling to be true at the beginning of the stage, so we'll say we have to reference the tag's value, but the tag's value, the tag's object, is in another script. So we're gonna have to do some code finesse to get the tags object referenced in this. To accomplish this, we are able to use a singleton, we are able to use static functions, or we are able to use dependency injection, and there's plenty of other ways to do it, but the way I'm planning to do it is to use dependency injection. Now to do that, I'm going to define a node, and I'm going to export it. I'm going to export a node path, and then from the node path get the node. So under exported variables, I'll put in export node path, and this is going to be the path to tags example. And on ready, we'll get the node. So here, tags example, we get the node from the path. Okay, so now we have access to the tags object through the tags example object. So now I can say tags example dot tags dot set tag. We can specify the tag, and the tag is also, oh yeah, why do I keep forgetting this? I gotta define the class name globally, but that's not a problem. I'll just go to the tags example and put in the class name over there, class name tags example. There, save the code and it should be fine, right? Yeah, no problem there. Okay, so we'll put in the tag, and to refer to the tags, since the tags are constants, we are able to use the tags example class name, global class name, and refer it like that, tag. I wonder why it's not picking up. Just hold on. Tags example constant tag. Yeah, it should be, isn't declared in the current scope. Oh, spelling mistake. Okay, there we go. Now we can set tag idling to true. Oh my gosh, let me just get some more space there. Okay, cool. Right, so now we're starting off with the tag idling being true. Now let's make it so that we have some interactivity. When I am idle, I want to start running when I press the right button. So let me get that typed up. So to start, let's begin with the logic. If I am idle, so according to the relevant functions, it would be tag dot get tag value. So to refer to the tags, I use the global name tags example, unexpected token if. Oh right, we gotta start off with the function, right? Of course. Process. Okay, if tags example dot tag idling dot get tag value is true. So if I am idle, if I press the right button, if input dot is action just pressed UI right. If I press the right button, become running. So I will say tags example dot tags dot set tag. The tag is tags example dot tag running. Set that to true. Okay. Let me just, for neatness sake, say that this is where I start running. Great stuff. Now the next logic is we want to stop running if we are running and we release the right button. So I'll just copy paste that for the sake of speed. I am speed. Gotta go fast. So I'll explain it here. If tag running is true, so if we are running, if action just released UI right, if we are running and we release the right button, then set tag idling to true, so we become idle again. And if I explain that to you with a mock-up in mind, if I'm running and I set this running button to true, I'm originally idle, and I set running to true. Running becomes true as a result, moving becomes true as a result, not becomes false as a result, idling becomes false. And when I set idling back to true, idling becomes true, not becomes true. As a result, moving becomes false, and as a result, running becomes false. So it, in a simple way, we're doing something complex here, and we're not worrying about all these conditions. We're just saying what we want, and the stuff happens automatically. So it's pretty nice. Okay. And now for visual flair, we're gonna just make the character, the player character, the actual kinematic body move. Alright, since this is going to be connected to a kinematic body, we should probably make this script extend a kinematic body. Yes, 2D. So when we are running, if the tag is running, tags example dot tag running dot get tag value is true. So if we are running, then move right, move and collide. Okay, so what we could just do is we could add a vector 2 here, but what is a good practice is to just define a constant, so that if you want to make changes later down the line, it's not such a huge thing to change the code. Look for that one particular function, look for that one particular line, and change the values. Now we're just going to define a function here. We're going to call it constant run value, and we're going to make it a vector 2, and it's just the amount of pixels in a frame that our play character is going to run when the character is in the running state. And then we can just add a run value back to the move and collide function. Okay, and hopefully that's that. Problem, expected a constant expression. Yes, is that not a constant expression? Oh, right, vector 2, spelling mistake. Duh. Okay, and for static typing sake, we can also infer the type. So let's get this code attached to the player character. We are done with the text editor, so let's get this maximized again. Yay, screen real estate. It's free real estate. Okay, without further ado, let's get this connected. Attach the script movement. Okay, and in this stage I'm gonna create, where is the scenes? In the stage I'm gonna create a new node that's gonna hold the tags. I'm just gonna make a regular node. I'm gonna call it tags node, and I'm gonna attach the script tags example, and this is gonna be the node carrying the tags instance, or the tags object instance. Okay, and now we are able to, oh, did I not save it? I gotta save it. Yeah, now we have the tags example path. If you remember, we gotta assign the node that's carrying the tags object, and now in our stage we do have a node that carries the tags object instance. Now we can assign it tags node. Okay, I hope that's everything. Just save it and then we can play it. Does everything work fine? No, there is an error. Non-existent function set tag. Oh my gosh, spelling mistake. Let's try that again. Great. Now our play character is moving, but we don't have any idea what's happening in the background, so let's get some debugging going on here. To do that, simply I'm going to create a new scene. It's going to be a user interface, a simple panel and a label. I'm going to name this thing tags debug, just so that we can see the values of the tags in the background. Okay, and I'm gonna make it a built-in script, just for, or maybe, no, I'm gonna make it a built-in script just for the sake of laziness. Okay, and we'll do this real speedy. So we want to reference the tags object, so that we can get the list of tags and we can see their values. So to do that, we're going to use the same method of exporting the node path and then getting the node from the node path. So we'll export this. We'll export the node path, and let's just call this tags example path, and then public variables. No, it's actually onReady for tags example is equal to get node tags example path. Right, now we'll be able to refer to the tags object, and what we want also is we want access to the label so that we can display things on screen. So onReady for, let's just call it the label, equals get node, and now we can just put in the node path, the static node path. And in the process function, so every frame we want to update the label's text. So the label dot text is equal to, and what do we want it to be? We want it to be all the tags. Now the tags object has a nice convenient function, a two-string function that automatically lists the tags names and their values. So I'm just gonna go ahead and say tags example dot tags dot to string, and that should hopefully work. We'll see. Save that. Oh no. Save the scene. Save the scene as tags debug. Good practice is to not put capital letters in file names. That's according to the PEP8 standard. Okay, and in our stage we'll add that. Tags debug. Oh boy, yeah. Okay, let's get those proportions correct. Okay, let's just make it a solid size 320 by 320. That seems appropriate. The panel as well. Okay, and the anchor I want to be 1 so that when I resize it What in the world? Okay, never mind. You know, I'm not very good with these control nodes. I'm just gonna save it and be happy with whatever the result is. So if I play it, what I want logically is that. Oh yeah, I forgot to assign the path. So here's also I gotta assign the path. Gotta assign it to the node that carries the tags instance. Yep. What I want is the tags to be displayed on screen. Oh boy, what's happening here? Did I name all the tags? Are my tags named? What? What? Okay, I'll just name them. That's fine. Live debugging. I really thought I did, but you know, with all the times I recorded these episodes or this very video, like getting so confused. But it's fine. Okay, so save that. When I play the game, it should show me the tag names and their values, and when I press right, you'll see that running will become false along with the dependencies being satisfied. So here I go, pressing right. As you can see there, running, moving, and not moving change values. So currently I'm idle, I'm not moving, so not moving is true, but when I do become moving, not moving becomes false, moving becomes true, running becomes true. And also the OR is satisfied when I am running. So when I'm running, the OR becomes true as well. And we all did that through like 6 lines of code, right? And as you add more features, the the amount of code that you're saving on becomes immense, and that is, I think, an appropriate amount of project that we did here. You can kind of understand that if we were to do the same with jumping, if we were to do the same with walking, um, we, all the dependencies will be satisfied as well. So that's fine. And I think, I don't know what more. Maybe I'll release this project online. I don't know, but it is here on the video. So if you feel like this tool is useful, go ahead and make use of it. If not, that's also alright. But either way, I think that's all for now. Peace out.